area between two curves. This says let f of x and g of x be two continuous functions over the interval a, b. If f of x is greater than g of x for any value of x in a, b, then the area between f of x and g of x from x is equal to a to x is equal to b is given by the area between the curves is equal to the integral from a to b of f of x with respect to x minus the integral from a to b of g of x with respect to x. All right, so the diagram below illustrates an example, or is an illustration of an example of the area between two curves. So both curves are continuous over the region from x is equal to a, to x is equal to b. The graph of f of x is above the graph g of x. Therefore, the shaded area, which is the area between the two curves, is given, as stated before, as the integral from a to b of f of x minus the integral from a to b of g of x. All right, let's have a look at an example. Example 9. In example 9, we're asked to calculate the area bounded by the curves y is equal to 2x and y is equal to x squared when x is greater than 0. So one of the first things I would probably do with this question is to try and get a sketch of the graph. And so the first thing I'd want to know is where the two graphs intersect. Now, at the point of intersection, the two graphs are equal. So x squared is going to be equal to 2x. So this only occurs at the point of intersection. The point of intersection is one point that is common to two graphs. Therefore, at the point of intersection, the x-coordinate for the two graphs and the y-coordinates for the two graphs are the same. So the y-coordinate for the two graphs, which is x squared and 2x, at the point of intersection are equal. So let's solve this equation. We're going to have x squared minus 2x is equal to 0. X is common, so I have x, and then I have x into x squared is x, minus x into 2x is 2, is equal to 0. If I'm multiplying two numbers that I'm getting 0, it is either the first number that is 0 or the second number that is 0. So from this, I can say that the two graphs intersect where x is equal to 0 and where x is equal to 2. All right, so those are the values of x at the point of intersection. Now, since the point of intersection is common to both graphs, I can use any equation to determine the y-coordinate. So y is equal to 2x. I'm going to say when x is equal to 0, y would be equal to 2 times 0, which is 0. So 0, 0 is a point of intersection. Y is equal to 2x, and I'm going to say when x is equal to 2, y would be equal to 2 times 2, which is 4. So 2, 4 is another point of intersection. So these are my 2 points of intersection, 0, 0, and 2, 4. Now only 2 points are needed to plot a straight line graph. Therefore, if I just line up these 2 points, and draw a straight line through them, this will be the graph of y is equal to 2x. All right, we should have known this, or we at least knew that the graph was going to look like this. Any graph in the form y is equal to 2x, in the form y is equal to mx, is a straight line that passes through the origin. So again, if I draw a graph of any function in the form y is equal to mx, it is a straight line that passes through the origin. M is the gradient. So the gradient of this line is 2, and it is a straight line that passes through the origin. Now, we already know 2 points on the graph of y is equal to x squared. I probably just need one more, and I know what the graph is going to look like. It is a parabola that is symmetrical about the y-axis. All right. So we have y is equal to x squared. I can say when x is 1, y would be equal to 1 squared, which is also 1. So the point 1, 1 is a point on the parabola. It's a point on the parabola y is equal to x squared. So I have 3 points now, so I can probably do a rough sketch. All right, not having a very good sketch day. So let's do that over. All right, being the perfectionist that I am, I'm going to want to get a little better. All right, so this is a better, and of course, this is the region that I want to determine the area of. It is the region between the line y is equal to 2x and the curve y is equal to x squared. So, of course, now the shaded area would be equal to the integral of the one that is above is y is equal to 2x. So it's the integral of 2x from is the integral of, let's just sort of write a formula just to show a context. So a to b of g of f of x dx minus the integral from a to b of g of x dx. It's sort of like a formula. In our context now, the graph that is above is y is equal to 2x. So this is from 0 to 2 of 2x dx minus the integral from 0 to 2 of x squared dx. All right, so this would work out to be, let's integrate. If we integrate, we're going to get 2x squared over 2, and of course within the limits from 0 to 2, minus x cubed over 3, and again within the limits from 0 to 2. These two cancels. So this is, replace x with 2, we have 2 squared minus 0 squared, minus, replace x with 2, then I have what, 2 cubed over 3, minus, replace x with 0, 0 cubed over 3. All right, so this would work out to be 2 squared is 4, minus 2 cubed, which is 8, 8 over 3, which is the same as saying 12 over 3 minus 8 over 3, which is equal to 4 over 3 square units. So the area between the two curves, um, y is equal to 2x and y is equal to x squared is equal to that area. That area is equal to 4/3 square units. All right, let's see if we'd have time to do another. All right, here's a simple one. Example 11 says find the area of the shaded region bounded by the curve y is equal to sine x, y is equal to cos x, and the line x is equal to 0, which is the y-axis. So the shaded region is shown, and this area, so the shaded area would be equal to the integral from 0 to pi by 4 of the curve that is on top, which is y, which is cos x dx, minus the integral from 0 to pi by 4 of the curve that is below, which is sine x. All right, and then if I differentiate sine and get cos, if I integrate cos, I get sine. So this is sine x, of course, from 0 to pi by 4, minus, if I integrate sine, I get minus cos. So it's minus cos x, of course, from 0 to pi by 4. Next, we're going to replace x with pi by 4. So this is sine pi by 4 minus sine of 0 minus cosine pi by 4 minus cosine 0. All right. Now the sine of 0, it should have been 0, not pi. The sine of 0 is 0. So this is the sine of pi by 4, which is root 2 over 2, minus the cosine of pi by 4 is also root 2 over 2. A negative times a negative is a positive. The cosine of 0, which is 1. So next I can remove the bracket by applying distributive law. So I have the root of 2 over 2 plus the root of 2 over 2. A negative times a negative is a positive, minus 1. So this becomes 2 root 2 over 2 minus 1. So our final answer is root 2 minus 1, and this is square units. All right, and that is because you're finding area, this square unit. So therefore, the area between the curves y is equal to sine x and the curve y is equal to cos x between x is equal to 0 and x is equal to pi by 4, that area is equal to the root of 2 minus 1 square units.